All right. Hey guys, and welcome back. All right. So this is actually the fifth video in the series on torque and rotational motion that I have done today, of all things, which that's really irrelevant to what you're probably after. But anyway, let's go ahead and just get right into actually doing this one. So someone has wound like a rope around a solid cylinder. So somebody has wound a rope around a solid cylinder, and that's just telling us our moment of inertia. And they've actually, like, there is a rope or something, and they've released it. It's kind of like a yo-yo being released, is really what it boils down to. And so let's see if we can't try and create an equation to maybe solve the acceleration of this object. So let's just see what we can do. So let's go ahead and let's just go ahead right from the get-go. I'm going to go ahead and I'm going to place a beam across here. Do you have to do this? No, not at all. I'm just doing it to try and help you get like a start in doing these problems. That is my whole reason. So dead in the center of this object, we will have, I don't know if you've noticed it, but I always start with my force of gravity. We've got us an mg in the middle. Now, this one's going to be interesting because every other video I've done this just about. But this is not like those others. I'm going to, well, I was going to hit the undo button, but apparently my undo button is covered up. Hold on. Use the magic. Doom. So, every other video. So, let's try something. See if I can get my mouse to working here. So, this video, the last one we did, there was a normal force because this cylinder was sitting on the ground. The one before that, it was a cylinder on incline. There was this normal force. The one before that, there was a pulley mounted to an axle, and I put like a reaction force, an R, in that. But notice something. I'm not going to do that in this problem. I'm just got an mg because this is like a yo-yo that's being dropped. So it's not sitting on top of anything, nor is there an axle fixed to it. So the only other thing, see if we can get my marker back, is over here. Bam. We've got, we'll call that a tension attached to it. And so immediately then my response is say, well, let's do a sum of the forces x. Except I just wrote the letter E, so it's obviously getting later in the day for me. So sum of the forces x. I know you're saying, Mr. Cole, it's obvious. There's no x's. I know it's OCD. Just go with me. Hey, that could be a song. Hey, everybody got the OCD. Can't you go with never mind. Anyway, sum of the forces. Y, on the other hand, ooh, I don't want to do that. This object's falling down as it unwinds. So I'm going to do this. I'm going to write mg minus t equals ma for that object. And now let's just go ahead and go straight to the torque. So I'm going to pick my pivot point. I'm going to pick my pivot point to be the center of this object. So if the center is my pivot point, that means the mg doesn't make a torque. The only torque, Tr, is equal to, and the physics in this problem is over. That's it. So Tr, if you've watched these other videos, you should be crushing this thing now. Mr squared, since it's a cylinder, the alpha would just be A over R. R squared cancels R, the R. So once again, we've got a happy pirate. R, 1/2 M A. And so we've got, so there is our torque equation. There is our sum of the forces Y. So there's not much left here. So let's just go ahead and do something. Let's substitute back in. So let's bring this guy back into there. So we've got mg minus 1/2 MA equals MA. And it feels like we've been here before. Wait a minute. My M's are going to cancel out of this thing. So lo and behold, I've got G is equal to what we got over there. That's crazy talk. 3/2 A. So in the end, my answer, my acceleration is just 2/3 G. Now see if it makes sense as well. It's got to be less than gravity because gravity would be free fall, and so we do have something holding back. So there's got to be some form of, resistance here. So anyway, there is the solution to our problem. So anyway, thanks. I'm glad that you now know torque is equal to I alpha. I feel quite sure, drove it into the ground at this point. Anyway, I want to say thanks for watching. I'd like to also thank my sponsors. I don't have any sponsors. If anybody's looking to recruit a physics dude, then Turd Ferg 67's always looking. So anyway, because yeah, no joke, I got kids, so I could use the money. So anyway, all right, deuces, bye.